Our last lesson for this unit, our lesson 7, slope. We're going to learn about slope and what that does. It's a very specific ratio we're going to talk about. It is proportional. It is a ratio. It's really a culmination of all of the different things we've looked at. It's a ratio between y over x. It's a constant rate. It's proportional. It can be proportional, sorry. It's all about this idea. So we're really going to look over this and explain how this works. So the goal was by the day is you can find the slope of a line and you can interpret what the slope of a line represents. So let's take a look and get started on that idea. All right. First things first, we need some vocabulary out of the way. We need to know what is slope, okay? Slope is really just a rate of change. So I'm gonna type this just to make it easier to read. So it's a rate of change. Ooh, that's too tiny to see. It's the rate of change. It's a rate of change. Okay, so just like it's a type of that same idea, but it's a specific one of y divided by x. Okay, it's really the change in y over the change in x. So that's really what we're looking at. It's a rate of change, but specifically another way you say y over x. You can also see some people say it's rise over the run. You know, people will say it's rise over run, it's rate of change, it's all these things. But slope specifically is this idea of how much do you change going up and down, up or down, and then to the right. Okay? So let's take a look and see how that works. So first things first, we can find it multiple ways. The most common way we are going to work on it today is looking at it between 2 points on a graph or a given line. So we pick 2 points. I'm going to switch this color to a nice bright pink so we can see it real easy. You can see here's our first point, here's our second point, and then we actually have 3 points on this graph. We're going to see it's the same as we were looking at yesterday as we were taking a look at our constant rate of change. This is a constant rate of change. It is not proportional because it doesn't go through the zero. Okay, but we'll see here, okay, how much does it go up? 1, 2, versus how much it moves to the right. So you would say the slope is 2 over 1, and then you'd simplify it one more time to 2, just like it shows here. So let's take a look at a couple of these. We can graph slope, we can use slope, we can talk about slope, we can find slope. So that's all we're going to take a look at this problem. So the table shows the relationship between the number of seconds y, that's our dependent variable, that it takes to hear thunder after a lightning strike. That's the miles at x. So x is our independent variable, y is our dependent variable. And we'll go ahead and label our lines. This is right here, this is our miles. This is our seconds. I can't write really neatly upside down, so I'm just going to write S for seconds. Graph the data and find the slope. So first thing we do is we know how to graph this. So our first one, we're going to say the seconds, we're going to go every 5 seconds. We're going to make this for 5. That's our scale. So 0 seconds, 0 distance. You can hear it instantaneously. 1 mile away, 5 seconds. 2 miles, 10 seconds. As we keep going up the line until we hit 5. This is my slope. This is my rate of change. And since I have this being 5, 10, 15, 20, 25, we'll stop numbering there. And down here being 5. It gives us that idea. So now what we can say, okay, we can come down here and go, I've graphed the data. My slope is going to be y over x. So we're going to go right to our rate of change, our unit rate. We talked about being our constant rate of change and use that. Our slope is 5 miles per second. So that's its distance. That's our rate of change. That's our slope. And that's exactly what it represents. That every 5 seconds, that's what the slope represents. Every 5 seconds, the sound you hear from the lightning strike travels 1 mile. So if you hear it 5 seconds away, that lightning strike was a mile away, and so on and so forth as you look at it. I want you guys to give that a try. Pause the video and see if you can figure out both the slope and on the line, and tell me exactly what this slope represents. All right, so the table below shows that relationship between the number of hours Hudson worked and the amount of money he earned. Graph the data on the graph. So I'm going to set this up again. I'm going to set this up this time at, let's say everything is 15. So I'm going to label this as dollars. Again, it's hard to write sideways, so I'm just going to label with a dollar sign. This is going to be our hours. Make my H a little better. So this is 15 This will be 45. That'll be 75, 90, 105, 130. Okay, so I've got all my numbers listed. So at least I've got my scale here. So I know after 1 hour, 3 hours, he's made $45. That's my first point. For 6 hours, he's made $90. That's right here. And for 9 hours, he made $135. So I wrote that wrong, 135. There we go. Right here. So we can see if we were to create this graph, okay, we see this. This time we can see it's proportional because that goes through the origin if we followed our line perfectly. And it can keep going. So we've got our slope, where this time our slope is not as easy as just finding a unit rate. So I've got to find the change in y over the change in x. And that leads me to say, okay, the slope is 15. So what the slope represents is that Hudson here makes $15 per hour at his job. Whatever he does, he makes about $15 an hour. All right, so let's take a look at what we might find here. Henry opened a savings account. Each week he deposits $300. So I've already got the graph drawn, okay, of the account balance of time. Find the numerical value of the slope and interpret it in words. So I'm looking at this, okay, what is slope? Slope is that rate of change. So we've got this same idea. So each of these blocks stands for 300, up 300 to the right one. So the numerical value of slope is 300. And that means exactly what we see, that his slope, so his bank account this time, so let's call Henry's. So we can't use a pronoun before we have our antecedent here. Henry deposits or puts in $300 per week. And what that means, period, his bank account increases by $300 a month. By $300 per week. Okay, so that's our idea of how this is. It's your turn to tell me what you can interpret. It's a graph from Mahalia. Drains a 20-gallon aquarium at a rate of half a gallon per minute. Draw a graph of the water and aquarium over time, finding the numerical value for the slope. Now, before I let you jump into this, I'm just going to kind of give you a hint. Use your halves. So this is going to definitely be your gallons, because here's your minutes down here. Here's your gallons. I would recommend, okay, you start with the idea of each one being 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, go ahead and graph this one. You will not finish, you won't hit all the way to the bottom, but it'll get you a good start. All right, pause the video, see what you come up with for your graph. All right, now that you've got this, let's go ahead and see. So your first thing you do is you graph 0, 20. At 0 minutes, it's not drained at all. 1 minute, it's gone down half a gallon. 2 minutes, you're down to 19. Another half a gallon. 4 minutes, you're down to 18 gallons. You can see this is a really, really slow process. It doesn't have to be exactly perfect because you are doing it with some fractions. But you can see how this is this tiny, it's a very slow process that she's dumping out this water. Okay? So again, now I've got my numerical value. So I'm going to look at here now. I'm going to say, okay, I got 20 gallons, half gallon a minute. So it's going down a half over 1. So what's my slope? I'm going down 1/2 to the right 1. So I'm going to have 1/2 over 1. So my slope would simply be just set as 1/2. Now, the thing about this is since I'm going down, it's not like I'm increasing over time. This is my first opportunity where I have to look. You're right. It takes a negative number. It decreases. It's draining. Okay, so my slope is actually negative 1 over 2, down 1/2 over 1. And since it's unit rate, we don't have to put it over 1. Okay, so you're going to tell me in words. The aquarium loses a half a gallon per minute. Okay. All right, let's take a look at another one. And that's the last one. Actually, that's the last one we're going to look at today. So that gets us kind of talked through slope. If you have questions, feel free to reach out. I'd be happy to help. All right. Good luck. If you have questions, please reach out.